Okay, so good day everyone. So this topic is all about discrete probability distribution. Okay, so in terms of discrete probability distribution topic, so we will have two parts. Okay, so in this video or in this recording, I will just discuss the part 1 and we will discuss the part 2 on our next meeting. Okay, so the contents of this discrete probability distribution are the following. First, discrete uniform distribution. Second is we have the binomial distribution. Third is we have the negative binomial and geometric distributions. Fourth, we have the multinomial distribution. Next is we have the hypergeometric distribution. And lastly is we have the Poisson's distribution. Okay? So in this recording or in this video, we will just discuss the free. So we will discuss discrete uniform, binomial, negative binomial, and lastly, we will discuss the geometric distribution. Okay? So before we discuss the following types of distribution, so let's have first a review about what are the properties of a discrete probability distribution. Okay? So we have two main properties that we need to remember in terms of discrete probability distribution. Okay? Always keep in your mind, okay, that the value of the probability of a certain discrete random variable is between 0 and 1. Okay? It means the value is what? Okay? So if you talk about property number 1, the value of our probability is what? A non-negative. Okay? So if we say about non-negative, okay, the value is not a negative number. Okay? It means the value of probability, okay, is greater or equal to 0 and less than or equal to 1. It means the value is from 0 to 1. Okay, and again, non-negative. So if there is a negative number present in a certain distribution, it is not considered as a discrete probability distribution. Okay? Next, property number 2. The sum of all probabilities is 1. Okay? So like I said last time, okay, in our meeting or in our lesson, okay, if you add all the probabilities, chances, or all the chances, or all the probabilities present in a certain event, okay, the sum of all probabilities should be always equal to 1. Okay, so that is for our second property. Always remember the two properties. The first property, the value should be between 0 and 1 only. Therefore, there will be no negative numbers, okay, and the value is maximum, the maximum value is equal to 1 only. Okay, just remember again, non-negatives, and the second property, the sum of all probabilities is equal to 1. Okay, so let's have an example here of determining a certain table or distribution, whether it is a probability distribution, discrete probability distribution or not. Okay? So let's try these examples. Okay. So let's start determining the table number 1 here. So we have table number 1. So we have the classes here in the upper columns or upper rows, okay? And you have the probability in the lower rows here, okay? So in terms of classes, we have 2, we have 4, and we have 6. So the following probabilities is we have 1/2, we have 3/4, and lastly we have negative 1/4. Okay, let's observe the table. Okay, so look closely in the table. Okay, so in terms of 6 class, okay, it has, okay, a probability of negative 1/4. Okay, if we go back to our first property, okay, the first property, okay, it said that what? the value should be a non-negative. So if we have negative value here, okay, in our class 6, automatic, this distribution or this table is not a probability, or it is not a discrete probability distribution, because like I said, we have a negative value. Okay? If you find a certain negative value in a certain table, okay, automatic, it is not a discrete probability distribution. Always remember, class, if there is a negative value on a certain table or in a certain distribution table, automatic, it is not a discrete probability distribution. Okay, remember that. Negative, automatic, not a discrete probability distribution. Okay? Second table. So, based on our property number 2, okay, so the sum or the summation of all probability is equal to 1. So, let's check if this table is equal to 1. Okay? So, we have 1/8 plus 3 over 8 plus 1/2 plus 0. 1/8 plus 3 over 8, we have 4 over 8 plus 1/2. Let's simplify 4 over 8, we have 1/2 plus 1/2. So if we add 1/2 plus 1/2, we have the value of 1. So we proven, okay, that this distribution table is what? Considered as a discrete probability distribution table. So that's how we determine a certain distribution table, if it is a discrete probability distribution or not. So remember the two properties, because if you don't know the two properties, you can't determine a certain table. Okay? Again, the value should be non-negatives and the maximum value is 1. Okay? And always remember, the sum or the summation of all probabilities is always equal to 1. Okay? Remember the two properties. Again, example number 2. So, if we have some unknown in our table, so we can find the value. Okay. So, we have this table here. So, we have different classes and we have different probabilities. So, for the 0, we have 0.06. For the 1 is we have the 0.23. For the 2 is we have unknown. So, if there is an unknown, okay, so it's much better for us to denote a certain variable. So I think we can use the variable x. So the value of the unknown is equal to x. Okay, so later on we will solve for the x. Next, for the category 3 or the class 3 is we have the 0.35, and for the class 4 is we have 0.05. Okay. So we have different records here. So we have A, B, C, and D. So, okay. So first, let's find the value of A. So in A, we need to find the value of the unknown. Okay. So how we can find or how we can solve for the value of the unknown? So based on our property number 2, the summation of all probability is equal to 1. Therefore, we will just add all the probabilities and we will equate it to 1. Okay? And that way, we can solve for the unknown because we can simplify the equations. Okay? So, we have 0.06 plus 0.23, okay, plus x plus 0.35, sorry, plus 0.35 plus 0.05 equal to 1. Okay? So, if we apply algebra rules, so we will just what? Transpose the value and subtract it to 1. So, our x is equal to, what is the value of x? We have 0.05. 31. So the value of our x, or the unknown, is equal to 0.31. Okay, next, letter B. Find the value of probability, find the probability if the y is greater or equal to 3. So we will find in this table, or we will observe the table. So what are the values equal or greater than the 3? So the values greater and equal to 3 is what? We have the P3 and we have the P4. So the next step is we just need to add the values. Okay? So next step, add the values. You have P3 plus P4. Okay? So what is the value of our P3? We have 0.35 plus 0.05. So if we add the value, we have the total number of probability greater than or equal to y. We have 0.40. Okay, so for the letter B, so the probability that the value is greater or equal to y, or to 3, greater or equal to 3, is we have 0.4 because we add probability 3 and probability 4. Okay? Letter C. Find the probability, okay, if y is less than 2. Okay? So how we can find a certain event if there is a probability less than 2. Okay? So it's observe the table again. So what are the numbers less than 2 present in the table? So we have 0 and we have 1. Okay, again, in order for us to solve for the total probability, we will just add the values. Okay? So we have probability 0 plus probability 1. Okay, so substitute the values. 0.06 plus 0.23. We have 0.29. So the value is equal to 0.29. Okay? Last letter. We have letter D. So for the letter D, find the probability if y is greater or equal to 1 and y is less than, okay, is less than 3 or less than or equal 3. Okay? So if we observe the scenario, okay, so the y is equal to 1, okay, and y is also equal to 3. So automatic 1 and 3 are considered. Okay? And it is said in the problem, greater than 1 but less than 3. So automatic 2 is also considered because it is the middle of 3 and 1, and based in the given or the required, the y is also equal to 1 and the y is also equal to 3. So 2 is also considered. So we will just add P1, P2, and P3. So we have P1 plus P2 plus P3. Okay? So we have 0.23 plus 0.31 plus 0.35. So the value of D is we have, what's the answer in D? So we have 0.89. Okay, so that's how you solve a certain discrete probability distribution. Okay, so don't be confused, just follow the process and you will determine a certain distribution table. So you will determine or prove if that certain probability distribution is a discrete probability distribution based on our properties. Property 1, a non-negative. The value is only between 0 to 1. And the second property, the sum of all probabilities is equal to 1. Okay? Next is we have discrete uniform distribution. Okay? Always remember, in terms of discrete uniform distribution, okay, so we are talking about the word uniform. Okay? So if you talk about the word uniform, okay, so we are dealing with what? The word same. Okay? So we're dealing with same values. Okay? In terms of uniform distribution, we have a formula for that distribution. So we have probability of x is equal to 1 over b minus a plus 1, wherein b, okay, is the number of total outcomes. Okay? And a is a certain outcome. Okay? Always remember, like I said, in terms of discrete uniform distribution, okay, so we are dealing with same values. Okay? For example, so picking a result from the throw of die, so in terms of getting a 1 in a single throw of die, the probability is equal to what? 1 over 6. The probability of getting a 2 in a single roll of die, we have 1 over 6 again. And the probability of getting a 6 in a certain roll of die, one roll of die, is equal also to 1 over 6. Like I said earlier, in terms of discrete uniform distribution, okay, the values of all probabilities present is just the same. So if we observe this, 1, 6, 1, 6, and 1, 6. Okay? So always remember again, in terms of discrete uniform distribution, we are dealing with properties or probabilities with the same values. Okay, so if you observe a certain probability that all values are the same, automatic, it is an example of discrete uniform distribution. Okay, remember that. The word same, it is discrete uniform distribution. Okay, remember and keep it in your mind. Okay, next. Next is we have the binomial distribution. Okay, so the experiment consists of n repeated trials. So we have two possible outcomes. Okay, so we have outcomes of success and we have outcomes of failures. Okay, so also the probability of success is denoted by p, or is the same on every trial. And always remember that the trials are independent. So we will explain later on. So we will have examples in order for us to determine how to solve a certain problem under the binomial distribution. Okay? So it is just a visual representation. So the success is the colored one or the solid circles, and the failure is the hollow circles natin. Okay? So the formula for binomial distribution is we have the probability of x is equal to NCX, wherein this NCX is also the same as NCR, wherein it is our what? Combination. Okay? So multiplied by p raised to x multiplied by q raised to n minus x, wherein n is the total number of trials, x is the number of successes, p is the probability of successes, and q, okay, and q is the probability of failures. Okay, so how can we we came up with this formula? Okay, so how in this condition, I mean, okay, so always remember the p is the probability of successes and q is the probability of failures. Always remember, if you add the total number of successes plus the total number of failures, okay, it is equal to 1. Okay, so how we can prove it? So based in this visual representation, okay, so we have 10 chances. Okay, so we have 4 successes and we have 6 failures. So if we add it, we have the total value of 10. Okay, it means the total value of probability of successes plus the total value of probability of failures will be equal to 1. Okay, so just remember, so how we can prove this formula or this condition. Okay, So if S or successes is equal to P, okay, and F or failures is equal to Q, so equal to 1. Okay, so if we simplify the problem, okay, the value of Q, okay, so if we transpose it, so the value of Q is equal to 1 minus P. Okay, so we proven a certain condition by using derivation. Okay, so remember, that's how we derive a certain value of Q. Okay, so Q is always equal to 1 minus P. Okay? Okay? Okay, so let's have an example. So example number 1, you are taking an exam with 7 questions. Each question has 5 answers with only one correct answer. Okay? So find the probability of answering 3 correctly by making random guesses. Okay? So let's talk about on how we can determine givens. Okay? So always remember, guys, class, that the value of n, okay, is always greater than the value of x. Okay, so in terms of binomial distribution, okay, the value of n is always greater than the value of x. That is the clue on how you will determine a certain given in terms of binomial distribution. Always remember again, the value of our n is always greater than the value of x. Okay? Okay. Let's start. So find the probability of answering 3 correctly by making random guesses. So let's start with givens. Okay? So we have probability. Okay? So what is the value of our probability? Okay? Based on our problem, okay, so let's read. So each question has 5 answers. So this can be also called as choices. Okay? So out of 5 answers, you have how many correct answer? 1 correct answer. So our probability is equal to 1 out of 5 or 1 over 5. Next, we need to determine the n and x. And like I said earlier, the value of n is always greater than the value of x. So 5 and 1 is already excluded in the choices because it is already our probability. Okay. So what are the numbers present in the problem? Okay. So we have 7 and we have 3. So automatic 7 is our n and 3 is our x because based on our condition or relationship, the n is always greater than the x. Okay? And the value of q, always remember, 1 minus p. So we have 1 minus 1 over 5. Okay? For the required, we need to find the probability of x is equal to 3. Okay? So for the equation, we just need to write the formula. So we have probability of x is equal to ncx multiplied by p raised to x multiplied by q raised to n minus x. Okay? So for the solution, you have probability of x is equal to 3. So let's substitute the values. We have 7 c 3 multiplied by the value of p. We have 1 over 5 raised to 3. The value of x multiplied by 1 minus 1 over 5, the value of q, and 7 minus 3 because we have n minus x. And for the answer, okay, so let's try using a calculator in order for us to solve the answer. Okay, so I show my calculator here. Okay, so we have quantity 7, shift, combination C, 3, okay, times 1 over 5 raised to 3 multiplied by 1 minus 1 over 5 raised to 7 minus 3. So we have 1792 over 15625, or we have 0.115. Okay? So the answer, the probability of x is equal to 3 is equal to 0.115. Okay? So that's how we solve a certain binomial distribution. Okay? Next, example number 2. So let's solve for the example number 2. So consider the example again with 4 multiple choice questions of which you have no knowledge. So what is the probability of getting exactly 3 questions correct? Okay, so let's solve the problem. So let's start with the givens. So let's start by determining the probability. Okay, so in this case, in this problem, we have a certain 4 multiple choice questions which you have no knowledge. So it means the probability of getting a correct answer if you have 4 questions. Okay, so in terms of 4 multiple choice question, we just have 1 chance. So it means out of 4, we have only 1. So the probability of this problem is equal to 1 over 4. Next, we will determine the n and x. And like I said earlier, okay, the value of our n, okay, is always greater than the value of x. So what are the numbers that are still present in our given? Okay, so we have 4 and 3. So automatic, the 4 will be our n and 3 is our x. Okay, so for the q, we have 1 minus 1 over 4. So for the required, we need to get the probability of x. Sorry. The probability of x is equal to 3. So for the equation, just write the formula. Probability of x is equal to ncx multiplied by p raised to x multiplied by q raised to n minus x. So for the solution, we have probability of x is equal to 3 is equal to quantity or 4 c 3 multiplied by the value of p 1 over 4 raised to 3 multiplied by 1 minus 1 over 4 minus 3. So we have answer. So let's solve using the calculators in order for us to be reminded and guided again, in order for us to be guided on how we can solve this problem by using the calculator. So we have quantity 4 shift c 3, okay, times quantity 1 over 4, okay, raised to 3 multiplied by 1 minus 1 over 4 raised to 4 minus 3. So if we solve it, we have 3 over 64 or 0.47. So we just stick with 3 over 64 for the answer. Okay, so the answer is we have the probability of x is equal to 3 is equal to 3 over 64. So that's how we solve a certain binomial distribution problem. Okay? Example. So let's go to example number 3. So a basketball player, traditionally it makes 85% of her free throws. So suppose she shoots 10 baskets and counts the number she makes. What is the probability that she makes less than 5 baskets? Okay. So let's solve this problem. So first we will determine the givens. Okay. So let's start with givens. So in terms of this problem, so if we observe this problem, we have this percentage. And always remember, if the problem has a percentage, automatic, it is your probability. Okay? And one thing that you need to do in order for us to use that value is what? We need to convert a certain first percentage value into what? Decimal. So what is the decimal value of 85%? We have 0.85. Okay? Next, we have the n. And we have the x. Automatic, our n is the greater one, so we have 10. And what is the value of our x? Is it equal to 5 or not? Any idea? Is it equal to 5 or not? So let's read the problem again. So what is the probability that she makes less than 5 baskets? So we need to find the probability of numbers less than 5. Always remember, in terms of probability distribution, you will start with 0. So what are the numbers less than 5? We have 0, 1, 2, 3, 4. It means we will have 5x. So we have x1 is equal to 0, x2 is equal to 1, x3 is equal to 2, x4 is equal to 3, and x5 is equal to 4. Okay? Then for the required, we need to find the probability of x, okay, less than 5. Okay? So for the equation, just write the formula. We have probability of x is equal to n cx multiplied by p raised to x multiplied by q raised to n minus x. Okay. So for the solution, so how we can solve this certain problem? So we can use a certain long method, okay, wherein we will solve all the values of probability in terms of 5x. So we will solve x1, we will solve x2, we will solve x3, x4, and x5, and we will add it, okay? But it is time consuming, okay? So I will introduce a certain shortcut method, okay, in order for us to solve this problem in a way that we will save time and it is much efficient. Okay, so how we can do that? So we will use the summation or the sigma process. Okay, so write sigma. Okay, so what is the lower value? We have 0. What is the upper value? We have 4. And you will just copy. Okay, so substitute the values of n. So we have 10 cx multiplied, what is the value p? 0.85 x multiplied by 1 minus 0.85, 10 minus x. And what is your next step? Your next step is we need to input this equation in our calculator. So let's have a demo on how we will do it. Okay? Okay. So first step is we need to make the summation appear. So how we can do that? So shift E. So we have the summation. What is our lower value? We have 0. And upper value, we have 4. Next, we need to enter the equation. Okay, so we have quantity. Okay, we have 10. Shift C. Alpha X. And always remember, in terms of this process, okay, you will only use alpha x because we have this x here. Okay, again, in terms of using this process, the variable that is only allowed to be used is x. Okay, no other than x, just use the variable x. Okay, So multiplied by the value, so we have 0.85 raised to alpha x multiplied by 1 minus 0.85, okay, raised to 10 minus alpha x. So we have the answer of 1.38 times 10 raised to negative 3. So that's how we solve a certain problem using this approach. So we have the probability of x less than 5 is equal to 1.38 times 10 raised to negative 3. So we have this value. Okay? Example number 4. Traditionally, 70% of students in a particular statistics course at MMCL are successful. Okay? Suppose 20 students are selected at random from all previous students in this course. What is the probability that more than 15 of them will have been successful in the course? Okay. So like I said earlier, okay, so let's start with the givens. And we have percentage automatic. This is our probability. And the next step is we just need to convert the percentage into decimal. So we have 70%, therefore we have 0.70. Okay. Next, we will determine the n in x. So automatic, our n is the bigger one or the much larger one value. So n is 20. So what is the value of x? Is it equal to 15 or not? So let's read the problem. From all previous students in this course, so what is the probability that more than 15 of them will have been successful in the course? Automatic, our x. So also, like example number 3, we have multiple values of x. Okay? So in terms in this problem, so based on this problem, we need to find the probability that more than 15. Okay? So we will find a certain values, okay, of numbers more than 15 up to 20. So we have 16, 17, 18, 19, and 20. So we have 5x. Sorry. Oh God. Okay. So we have x1, 16, x2, 17. We have x3 is equal to 18, x4 is 19, and x5 is we have 20. Okay. So for the required, we need to find probability of x greater than 15. Okay? So for the equation, just write the formula. We have probability of x is equal to ncx multiplied by p raised to x multiplied by q n minus x. Okay? So for the solution, let's use again the sigma 1. So we have sigma. What's the lower value? 16. Upper value we have 20 is equal to 20 cx multiplied by 0.70 raised to x multiplied by 1 minus 0.70 raised to 20 minus x. So the value of q we have, so I forgot, 1 minus 0.70. So for the answer, let's use the calculator. Okay. So again, first step, we need to input the sigma. So what is our lower value? We have 16, and upper value we have 20. Okay. So let's enter the equation. You have 20 c alpha x multiplied by 0.70 raised to alpha x multiplied by 1 minus 0.70 raised to 20 minus alpha x equals, we have an answer of 0.2375. Okay? So that's how we solve a certain problem like this. So we have probability of x greater than 15 is equal to 0.2375. Okay? Okay? Next, we will discuss the negative binomial distribution. So it's just the same as the binomial distribution, but we have a different approach and we have different formula. So in terms of binomial distribution, we have x and k. So there is no n in the formula, but we have a k and an n. Okay? So the formula of getting a certain probability under negative binomial distribution as we have here. So we have the probability of x is equal to quantity x minus 1, c, quantity k minus 1, multiplied by p raised to k, multiplied by q raised to x minus k. Okay? So how we can solve this problem? So let's try this. So another visual representation again, not so important. So we have this example. A pediatrician wishes to recruit 5 couples, each of whom is expecting their first child, to participate in a new natural childbirth regimen. Let P is equal to P, so a randomly selected couple agrees to participate. Okay, so if P is equal to 0.2, so what is the probability that 15 couples must be asked before 5 are found who agree to participate? Okay, so let's start determining the givens. So let's start with the given. So automatic, our probability is already given. So we have probability is equal to 0.2. Okay, so we just need to find what? We need to find what? We need to find what value? So we need to find k and we need to find what? The k and the x. Okay, and also p, the q, I mean, we have 1 minus 0.2. Okay? So if we observe the problem, so what is the bigger value? Okay, and always remember, in terms of negative binomial, the value of k is always greater than the value of x. Okay, so in terms of binomial, n is greater than x. In terms of negative binomial, sorry. Again. So in terms of negative binomial distribution, okay, the value of x, I mean, is greater than the value of k. Okay? So earlier, in terms of binomial, the value of n is greater than x. So in terms of negative binomial, the value of our x is greater than the value of k. Okay? So automatic, if we observe the problem, so what are the numbers that are still present? So we have 15 and 5. Okay? So automatic, the value of our x is 15 and the value of our k is 5 because, like I said, the value of x is greater than the value of k. So 15 is greater than 5. Okay? So for the required, we need to find the probability of x is equal to 15 and k is equal to 5. So that's how we write a certain required. For the equation, just write the formula. So we have probability of x is equal to x minus 1 c k minus 1 multiplied by p raised to k multiplied by q raised to x minus k. Okay, so for the solution, we have 15 minus 1 combination 5 minus 1 multiplied by 0.2 raised to 5 multiplied by 1 minus 0.2 15 minus 5. Okay, so for the answer, so let's use the calculator. So in order for us to solve this example, okay, so here's our calculator. So we have quantity 15 minus 1, shift combination quantity 5 minus 1 quantity multiplied by 0.2 raised to x, so we have raised to 5 multiplied by 1 minus 0.2 raised to n minus x, so we have 15 minus 5. So we have an answer of 0.03439. Okay, so our answer, so the probability of x is equal to 15, k is equal to 5, is equal to 0.03439. Okay, that's how we answer a certain negative binomial distribution. Okay, next question. Your basketball free throw percentage is constant at 33%. Okay. If you keep shooting free throws, what is the probability that you take 7 shots before you make your third made? So 8 attempt is the third success. Okay, so let's solve this. So let's start with the given. So automatic, we are given with a certain percentage. And like I said, if there is a percentage, automatic, this is our probability. So our probability is equal to 33%. So if we convert 33% to decimal, we have 0.33. Okay, so for the x and k, so what is the highest valued number? So in terms of x, so what is the value of x? We have 8 because 8 attempt. And what is our k? We have 3. Okay, because there is a third shot. Okay, and value of q, 1 minus p, so we have 1 minus 0.33. So for the required, we need to get the probability of x is equal to 8, k is equal to 3. So for the equation, just write the formula. So we have probability of x is equal to x minus 1 c k minus 1 multiplied by p raised to k multiplied by q raised to x minus k. Okay, so for the solution, we have quantity 8 minus 1 c 3 minus 1 multiplied by 0.33 raised to 3 multiplied by 1 minus 0.33 raised to 8 minus 3. So the answer, we have probability of x is equal to 8, k is equal to 3, is equal to, so let's use the calculator in order for us to answer this question. Okay, So let's start. So we have quantity 8 minus 1, shift, combination, quantity 3 minus 1, okay, multiplied by 0.33 raised to 3 multiplied by quantity 1 minus 0.33 raised to 8 minus 3. So we have answer of 0.1019. Okay, so that's how we solve this problem. So we have answer of 0.1019. Okay, always remember, in terms of negative binomial distribution, the value of x is always greater than the value of k. Remember that clue. Okay? So last topic for this part 1. So we will discuss the very basic geometric distribution. Wherein in geometric distribution, we will just have 3 available givens. So we have the P, or the probability of success. We have the Q, the probability of failure per attempt. And we have the X variable. Wherein we have a formula of getting probability of a certain geometric distribution. So we have probability of x is equal to p raised to 1 multiplied by q raised to x minus 1. So another visual representation. So let's try to solve a certain sample problem. Okay. So Baines had a string of bad luck on his search for a date. So suppose that about 10% of girls would be interested to date him. So what is the probability that the 5th girl she asked out would say yes? So Baines is in a dating journey. So we will need to find what is the probability of getting the 5th girl to say yes. Okay? So let's solve this problem. So let's start with the givens. So the probability, like I said, if there is a percentage, automatic, this is our probability. So our probability, we need to convert the percentage to decimal. So 10% is equal to 0.1 or 0.10. Okay. So for the x and q. So what is the value of x? We have 5th. So it is equal to 5. And our q, like I said, 1 minus p always. So we have 1 minus 0.10. So for the required, okay, we need to find the probability. The probability of x is equal to 5. So for the equation, we have probability of x is equal to p raised to 1 multiplied by q raised to x minus 1. So for the solution, we have p, x is equal to 5 is equal to, what's the value of p? Excuse me, we have 0.10 raised to 1 multiplied by 1 minus 0.10 raised to 5 minus 1. So for the answer, so p, x is equal to 5, we have, let's use the calculator. So it's much better for us to be guided, again, like I said. So we have 0.1, 0.10 raised to 1, so I think it's just the same, multiplied by 1 minus 0.10 raised to 5 minus 1. So we have an answer of 0.0656. Okay. So we have p, x is equal to 5, so we have 0.0656. So that's how we answer a certain geometric distribution problem. Okay. So last example. So example number 2. Your basketball free throw percentage is a decent 72%. So it's high. So it's a decent. What is the probability that your third attempt is the first to go in? Okay. So let's start with the given. So automatic, we will have a probability because we have a percentage here. So our probability is automatic equal to 0.72 because if you convert 72% into a decimal form, it is equal to 0.72. Okay? Then the value of x. So we have third attempt. So x is equal to 3 and q is equal to 1 minus 0.72 because always remember that p or q is always equal to 1 minus p, and we will just substitute the value of p, wherein in this problem p is equal to 0.72. Okay, so for the required, we have p, x is equal to 3. So for the equation, just write the formula given. Probability of x is equal to okay, so we have p raised to 1 multiplied by q raised to x minus 1. So for the solution, probability of x is equal to 3. So substitute the values is equal to 0.72 raised to 1 multiplied by 1 minus 0.72 raised to, what's the value of x? 3 minus 1. So the answer, so we have probability of x is equal to 3. So let's use the calculator again. Okay, so we have 0.72 raised to 1. So I think it's just the same again, multiplied by 1 minus 0.72 raised to 3 minus 1. Okay, so we have 882 over 15625, or we have 0.564. Okay, so the answer is equal to 0.0564. So that's how we solve certain problems under geometric distribution. Okay, so I think that's all for our part 1. And for the part 2, we will discuss the remaining topics, and also we will discuss the techniques on how we determine a certain question, what type of distribution will be used. Okay? So if you have questions about this recording or this video, my MS Teams message box is always open. Don't hesitate to question me or to ask questions, or you have clarifications, just message me in Teams and I will explain it to you. Okay, so I think that's all for this recording, and let us meet on our next meeting. Thank you and have a good day, everyone.